All right, so in this video, we're going to introduce the idea of total cost and total variable cost and show how it comes from the total product curve. So in the previous video, we went through the example of the total product curve. I reproduced the table here. We looked at units of labor per day and the number of jackets per day that were produced. So we had 0 units of labor, 0 jackets, 1 unit of labor, 1 jacket, etc., all the way through 7. Okay? So the next step is to say, how do we go from here and generate the cost side of it? Okay? So again, what we're starting with is the amount of labor. So normally speaking, in any sort of firm or industry, if you want to use labor, you have to pay labor. So what we're going to do then is take this units of labor per day and just attach a price to it. Let's just say it's $100 per day, and we can transform this table from simply an input-output relationship into more of a what we'll call a total variable cost relationship. But we'll get to that in a second. So if we have no labor, then the total variable cost, the cost of that labor, is 0. If we have 1 unit of labor, since we've said that the price of labor is $100 per day, then we have $100, and we have 2 units of labor, it's going to cost us $200, etc. Okay? And you can fill in the rest of the cells. So what we're starting to generate then is a relationship between jackets per day and total variable cost. Now you have to remember from your reading that the variable cost, or a variable input, is the input which will, if you change the variable input, it changes the output. Okay? So we have this total variable cost idea. We also have the idea of a total fixed cost. So the difference between a variable cost and a fixed cost is that, like I said, the variable cost or the variable input, if you change that variable input, it changes the level of output. The idea with a fixed cost or a fixed input is that it does not vary with the output. So if you produce a lot of a good or nothing of a good, you still have to use that fixed input. That means you have a particular fixed cost. So if we say, for instance, our fixed cost is $200, we're basically saying we have to incur that fixed cost of $200 regardless of the level of output. So if we want, so that's our idea of the total fixed cost. So that gives us an opportunity to say, okay, total cost is simply the sum of the total variable cost and the total fixed cost. So in that case, total cost when we use no labor is going to be $200, because $200 is our total fixed cost. Even when we produce nothing, we have to spend $200. An example of a fixed cost could be a mortgage, it could be the salaries you pay to administrative people, it could be the rent you pay on land. Again, all these are costs which are incurred regardless of the level of output. Okay, so when we produce 1 unit of output, our total variable cost is $100, but we still have to pay our total fixed cost, which is $200. So our total cost is $300. Again, total variable cost for the next level is $200. Add $200 of the fixed cost, we get that, etc., etc. Again, you can kind of continue working through the rest of the table to fill in the table. Okay, so we've generated a total variable cost using our price of $100 per unit per day of labor. And we've generated our total cost by simply adding our total fixed cost of $200 to that total variable cost. Okay, so what does that look like? Well, let's go back to our total product curve. We had this idea from the previous video that if we simply mapped that labor per day to the jackets per day, we would get this total product curve. Okay, so that was basically saying, tell me the number of labor units per day you want to produce, you want to use, and I can tell you how many jackets are going to be produced. Okay, so pretty straightforward idea. Again, you saw that in the previous video. So since we're simply transforming this number of units of labor by multiplying it by 100, if we turn this into the total variable cost, which is measured in dollars, you'd get the same graph. We get our total variable cost curve that would look the same based on these axes. So we transform the labor per day axis into a cost of labor per day and mapping on to the jacket. So just look at it. Instead of 1, you'd have 100. Instead of 2, you'd have 200. Okay? So the graph would look the same. But when we start talking about cost curves, we're actually going to change the axes. We're going to be talking about a graph where you have the output, jackets per day, on the horizontal axis, and the cost on the vertical axis. So basically what we're going to be saying is, tell me the number of jackets per day, and I can tell you the cost involved in doing that. So what is that picture going to look like? Well, we're still having the same, if we're looking at the total variable cost curve put into this new flipped axes, essentially, because again, we've already total variable cost, jackets per day, jackets per day. So all we're going to do is essentially flip this, and what that picture is going to look like, roughly speaking, is like that. So if you flip this, you get this picture. So this is our total variable cost. And the key thing is, you've got it at the origin. If you have no jackets per day, you're spending no money. And again, this is not an exact mapping, but you could take these, you could take this table and actually graph it, or look in the book. So you'd have this picture. What about the graph of the total cost curve? Now remember, all we're doing with the total cost is adding a fixed cost, a constant value, in this case $200, to the total variable cost. So all you're going to be doing is, so for instance, at 0 jackets per day, with our example of a $200 fixed cost, we just go up $200, and basically the difference between these two curves, total variable cost curve and the total cost curve, the difference kind of vertically is simply going to be $200. So all we've done in this video is simply show, working from that total product curve, we're generating a total variable cost and a total cost curve. So the cost curves come directly from that input-output relationship, and then we've also shown how if the graphs of the total cost curves come from the basic total product curve, that input-output curve, but the key thing to remember is that we're swapping the axes. So the pictures are going to look a little different. So this is just one of those things you're going to have to kind of get used to. So in the next video, we're going to start looking at taking this idea of the total cost curve and start generating the idea of average costs and the margin cost.